All right, so thank you for reminding me of that because I had totally forgotten to hit that button. So it is recording. All right, volume's okay. So I guess I'll just repeat really quickly. The exam, February 16th. It'll be a Word document posted on Brightspace. You have 2 hours from 6 to 8. So study everything that we've covered, basically read the chapters that we've designated, and that should be enough. All right, so today then, let's switch back to the whiteboard here. And like I said, a lot of this is already in the slides, so you can also take a read from there. But we're going to talk about the TCP session hijacking attack. Last week we talked about TCP reset, all the scenarios there, and and this is a similar attack. So there's only a few parameters that we need to modify. Now in this attack, I only need you to do this once. I almost want to say that I want you to do just the lab for this, but I think I'll just keep it together in the TCP IP attacks lab. And that's fine. It's just this problem. I always think it's a little bit more complex than the other ones, but it's fine if we just keep it in the document. So the TCP session hijacking, the idea is quite simple. You have, again, we're just going to do this in Telnet. So this one we can keep pretty simple, all right? So I'm not going to ask, obviously, anything other than Telnet. Just do Telnet. And really, you have several options here. And at this point, I'm going to let you decide what you do. I will go over all the options, but I really just need to see a couple of things. Okay, so you will need to explain this one a little bit in your lab report. You have a Telnet client and a Telnet server. Okay, and remember the attacker is going to inject traffic. Now remember that the connection is a Telnet session between those two, right? So what the attacker needs to do is the attacker needs to spoof a packet to mimic the traffic that is being sent from client to server. So it needs to impersonate that packet somehow. Okay, and then remember that when the server replies, it only replies to the client. It does not reply to the server. However, there are things that you can do. Like if you just add ls, right? ls is a command that will simply send information, let's say information, back to the client. So the server will never see it. However, there are other tricks that can be done. For instance, instead of ls, right, you could send other Linux commands that, for instance, open up an Apache server, let's say. So it opens up Apache, or it opens up some connection with Netcat, right? And it opens up a port. And then that way, when that port is open, now you can make a connection to that port. You see that? And so that's the whole point, is that you insert something that can open a port. You can insert something that actually there's a file. That's one of the things you have to do in your lab. There's a file. And so the file then can be sent back to the attacker, right? Or the worst of all things, you know, like the holy grail, a shell. All right, so you can do a shell. You can do a shell, and when you do a shell, a reverse shell type of thing, now you have basically, you can type any command. So now you can type commands here. Now we're not going to worry about permissions or anything like that for this, or of getting a root shell. That's not the goal. We just really want to do that. So really what I'm looking for in this lab, in theory, is that you would be able to insert something like ls or pwd and view data. Okay, that would be the first thing that I would recommend that you do for this problem, right? So insert ls pwd to view data. Second is that you would get a file. So you would steal a file, from the server. And finally, the third one is that you get a reverse shell. You see that? So that's really all I'm looking for in your lab report, these three things. How you do it, you know, you can do it with NetWalks and Scapy, you can do it with Scapy or NetWalks. It's entirely up to you. I don't, you know, I'm leaving this one. Now you've had enough experience all semester, you know, think of the first 4 weeks as a warm-up, right, for this one. This is the big one. And that's why usually when we are in the lab, this would be like a practical exam, but given the pandemic and everything, we're just going to do it as a lab kind of a thing. But if you guys want, just let me know, I guess. If you want this to be a full lab, you know, so you get more points for it, you know, we can do that. All right, so the plan is, please pay attention to this, because regardless of what the PDF says, right, this is what I want you to do only for the lab, for this problem. So for the problem, TCP session hijacking, right? That's what I want you to do. Send an LS or PW data, right, and view it. And then also steal a file from server. So that means that on server here, you have a file called secret.txt and put some very secret information in there, you know, and then you need to send that. So that's the blue line here. You'll need to send that data to the attacker. And the other one is to do a reverse shell, so that where you can type some commands. All right, so that's what we're going to discuss today. And that's pretty much the scenario, okay? It doesn't have to be fully automatic. You can use Wireshark and manually set the parameters. For the most part, because it's Telnet, you should be able to do this. Fully automatic, sorry, with a sniff and spoof if you'd like to try that, or C code, you have the C code as well. So I leave it really to your creativity to figure out, but it can be manual, you know, with Wireshark. So what is the challenge? So the problem, you know, we'll talk a little bit about the details, obviously. You can also just read the book, right? Everything is clearly delineated there. Look at my slides. I have some examples there as well for you to read. But I'll describe this today. That's why I usually like to dedicate a lecture to this, take it pretty slow, and then, you know, wrap it up. So now what's the challenge? The challenge is that we have that scenario, right? We defined already that a TCP session is established by basically IP, you know, destination IP, source IP, right? So those are, we could say also the client, probably client and server IP, client and server port numbers, right? So for Telnet, we definitely know this one's 23, so that's given. The IPs are going to be fixed, 192.168.1.3, 192.168.1.17. We can assume they're on the LAN, and then there's this source port here. This one you have to figure out, but it usually doesn't change that much. All right, and then there's the additional problem of the TCP sequence number, right? So there's that. And remember, when in this direction, there's an initial sequence, a random sequence number, and in this direction, there is another random sequence number. They're very big numbers, like 32 bits. So those are the values that you can get, okay? And you can get those from Wireshark if you'd like. Or you can automatically try to guess how to get them. All right, so that's really the trick. And then after that, you know, as we know, we have three options for spoofing the packets. We have C, C++. You know, students that figure this one out, you know, obviously that's the fastest, the most powerful, but might be a little bit harder. There's Scapy and Python, right? So that one, you can try that one. And then there's the NetWalks tool also. And I've already provided, this is going to be attack number 40, right? And that is in it already. I already provided those commands. They are on Brightspace, right? So I actually have to send two packets. If you look, a push packet and an ACK packet, if you take a look at them, that's really what's happening. So you push the data, and then you have an ACK to confirm, right? So because the system will expect a confirmation, so you need to send both packets, and they're both actually NetWalks 40. And if you look carefully, I've already provided all the fields except things like this and that. And so, but today I'll provide more. So today I'll definitely provide more before the end of class. I'll provide a lot of little details, and then you should be able to do it. However, it's not guaranteed that you'll get it to work right away, because I always let one part for you to figure out by trial and error. And it's really about finding the pattern. I always think of this problem as you need to figure out the pattern, and that pattern is in Wireshark. So grab up if you do everything digital, grab your tablet and your electric pen like I have here, or grab a pencil and a paper. You're going to have to write down those sequence numbers, right? Sequence numbers. And try and figure out the pattern until you actually get this to work. That's why it's sometimes, as I recommend it, try one of these three. So start maybe with ls pwd, then the file that you're trying to steal, and then finally the reverse shell. So if you've taken 372, before this class, all those details of Linux should be clear. All right, so now, but I will give you the commands also today. All right, so that's the general problem, right? The general problem, figuring out really these TCP sequence number, that's another one. And then finally, the payload, right? But for the payload, I will provide, I'll provide the payloads, basically. So I'll provide the payloads for these three, ls, how to do the redirection for stealing the password using netcat, and then also for reverse shell. One thing we might need to do is we'll need to take whatever that string is and encode it in some way that can be carried as a payload by the packet, but even that is provided. I think with a Python function, we can easily do that. It should not be too bad. All right, so now that we've laid out the problem for TCP session hijacking, let's kind of go over this in as much detail as we can, okay? So that's my plan, kind of go over the book, and then after that, I'll go over more concretely what you would do on the terminal in your CVM. So we're talking about TCP session So we're talking about TCP session hijacking. Okay, so we'll lay out a few concepts first. So we know this basically first we need to establish the the three-way handshake protocol, right? So that needs to happen first. So obviously you need to log in to the client, start the server, right? And initiate everything, right? So establish the connection. So the session, telnet session needs to be established first. And that's done through the three-way handshake protocol, which we've already discussed when we talked about denial of service. So the connection will be established, and this is called a TCP session. And from then on, the session, as I said, will be defined by the parameters, IPs, port numbers, and sequence numbers. Okay. So as you know, that's defined by IPs, the session. The session is defined by IPs for the client and the server and port numbers also for the client and the server, plus the sequence number. Okay, and then this is the session. For the problem, however, you also need to send the payload, right? So that's the additional component. So this is this signature basically is itself what is called what is referred to as the TCP session. So you might say, well, that's pretty easy then to spoof a packet, etc. And obviously, if this was the only what's only required, these four things without the sequence number, it would be pretty easy to basically spoof packets and take advantage of that vulnerability. However, additionally to this, you have the sequence number, which provides some additional security. Given that this is a very random and very large number, it would be very hard to guess. Okay. Okay, so we've talked about that. All right. So now let's take a look at an example here of how this works. All right. So let's take a look. And I provided an example, like a printed example of this in the slides. You can take a look at that one over there. Also, basically, what we need to know about TCP sequence numbers. So let's say sequence. Now let's define sequence and acknowledgement numbers. Okay. So the client on either side of a TCP session will maintain a 32-bit sequence, okay, number. It uses to keep track of how much data it has sent, right? So remember, that's what I had said, where you have, client and server. Each one has a sequence number. So this is a sequence number. And then on the other end, this has its own sequence number. Let's say like this is going to be I and this is J, right? So they're different from different points of view. Each one comes up with its own initial sequence number. And then these sequence numbers are going to increase by the amount of data. So that's where on each side of these devices, you have a buffer, right? So you have a buffer, and then you have a buffer over here, and then you get some data and it goes to sequence number, let's say X, right? And so the next sequence number would be X plus 1, right? And however, if you are guessing sequence numbers, you could say X plus D, where D is this, right? And so therefore you would put your data here. So, and this is a problem, right? In an attack, this is what you might do, but this is incorrect because the computer will not accept this data until all the data has been filled in, right? So that's the challenge in your problem, is that you just can't quite guess these you really have to know, okay, I need to know what the sequence number +1 is going to be so I can actually send some data that fits exactly in there. Now, one advantage with something like Telnet is that it's usually, it sends a byte, it sends a character at a time. So technically it's sending like 1 byte. And so if you think about it, you can sort of guess, well, it sends 1 byte, it sends 1 byte, it sends 1 byte. So then I can kind of guess by bytes, right? So I'll just take something and kind of offset by a few bytes, and then possibly, if you're lucky, the next few bytes that come in will fill in the gap just exactly so that then the computer will accept everything. However, when something like this happens, you have to ensure that this byte is a special character. It's a special character, like a new line character. So the idea would be that whatever gibberish this is, it gets ignored because you hit enter, and then whatever you wrote here will execute correctly. Okay, so that's kind of the trick there, is that you're trying to fill up that buffer. Okay, so if we want to think of it here, so again, there's a buffer that's receiving all the packets as they're coming in, and it's placing them. And usually in a perfect world, they would go in sequence, right? And everything would be complete with no gaps, and so the computer would accept it. Unfortunately, well, that's how it's supposed to work. For the attacker, though, they have the problem that they have to guess, and they may not know, what's that X + 1. And guessing it is pretty difficult because the numbers are sort of random there in the sequence. They're relative to the buffer, but they're random. So one possibility, as I said, is, trying to figure out some number and hoping that it kind of falls in there and it's an offset of bytes. But that's really a tough problem to kind of figure out. So the best thing that we're going to do, at least for our lab, is to look at the actual sequence number. Okay, so we want to get it. Okay, so that's the idea. So that kind of gives us an intuition for the sequence numbers. So, so let's think about it. So let's go back to the idea. So we have the sequence numbers. Now, another thing that needs to happen with these sequence numbers is that they need to be acknowledged. So there's one sequence number in this direction, and there's one sequence number in this direction. But then think about it, and then there's, like a packet going in this direction, and then there's a packet going in this direction. So this packet actually carries a sequence number and an ACK. And this packet over here also carries a sequence number and an ACK. Okay, so they carry both. So the trick is then that they always ACK the other one's number, right? So they always ACK the other one's number. So this has its own sequence number, but it's going to ACK the last sequence number that it received here. So it received that, it ACKs it back to the other computer. Okay, so just keep that in mind. And that's really what sometimes is a little bit confusing about this lab. But what I would say is, to simplify it, just focus on sequence number. Okay. So let's think a little bit about this. So the sequence number is included in each transmitted packet and acknowledged by the opposite host as an acknowledgement number to inform the sending host that the transmitted data was received successfully. And that's just basically the TCP protocol. Okay, we can also say that TCP sequence numbers increase if data is sent. So the sequence number increases if data is sent. Okay, and they increase also, and it increases by the amount of data sent, by the actual amount actual amount of data sent. So, think about telnet, right? So you're sending L, S, so they're incrementing by 1 byte, but not all the time, because you could also get several packets at the same time, and then you just need to kind of send the sequence number for the total of the data that has been received. So it's a little bit sort of like that. And so what we can say is whatever data the server received, it's going to take that amount, and that's what it uses to increment the sequence number. So let's look at an example of that, actually. First, we'll start with the three-way handshake, and then we'll continue with just sending a little bit of data. All right, so first, let's say we have the three-way handshake. In the three-way handshake, you could say there's no data here, because you're only sending flags, right? You're sending the SYN, the ACK flags, but you're not really sending data. So if we think of this, let's say we have, so the three-way handshake, no data. Okay, so we have on one side, let's say we have the client, and then on the other side, we have the server. So now we have that the client has port number 54,841. And then on the server side, you have, obviously it's TCP, let's say it's web, so it's going to be port 80. Okay, so that makes up the communication. So now you send, in the three-way handshake, you send a SYN flag. Okay, the numbers, these are not going to be the actual numbers, but just relative numbers here. So let's say I have, so what I mean by that is I'm not going to use like 20, write a huge number because it's too big. I'm just going to use the relative numbers like 1. I'm going to start at 1. Okay, and then I'm going to be adding basically the data, the length of the data. Length of data. Okay, so the first one then, these are relative numbers. Okay, and you're going to send sequence equals 0, let's say, and no ACK, right? So null basically, because you just started the communication. Let's just say this is null. Let's just say this is null. Okay, then on now you have, let's say, port 80, 4841. And now you get the SYN, comma, ACK, right? So 2 flags in that packet from the server back to the client. Here, again, sequence should be another number, but given that it is relative numbers, it started at 0. But think that the server also comes up with its own sequence number, but it's going to ACK this number, right? So it's going to ACK this one plus 1. So therefore, it sends you 1. Okay? And then the client is going to send back 80, the ACK, and that would complete the three-way handshake. And this is going to be now this sequence number, right? It's going to be sequence 0 because no data has been, or sorry, sequence 1, the next one, sequence 1. No data was exchanged, so it only increments by 1, and it acknowledges this one, right, from the side of the server. So it's going to be ACK equal 1. Okay, so they're basically ACKing each other. So here it's a little bit difficult to see because it's the three-way handshake. But now let's do the same process and let's just send like a little bit of data. So that way, if we increment with data, we can see a little bit better the effect. All right, so now we're going to say here, after the three-way handshake has been established, after the three-way handshake is established, right, so after it's established, now you can send data. Right, so once again, this is going to be, hopefully this will be enough space. Right, so now send data. Okay, so again, we're going to think of in terms of the server and the client. Right, so port numbers are going to be 54,841 and port 80 over here. So that tells you that that's the server. So now remember, this is where the three-way handshake has already been established, and you kind of know, okay, sequence number is 1. Okay, remember the direction that you're going in. So we're going to start from the client side, So you need to look at a packet from the client to the server. All right, that's a common confusion where students, okay, they want to send a packet from the client to the server, but they look at the packet from the server to the client. And so think about that when you're doing this problem. So let's go back over here. So the first thing that's going to happen is the client is going to send some data, whatever it is, right? So let's say, send 725 bytes of data, right? So this packet is going to be a push and act packet, which is what I was saying. So you're pushing the data, and the length of the data is going to be 725. That's the amount of data that you have sent, okay? So you kind of know in the buffer of server, you were at 1, but now you've added 725. Oops. So you're really 1,725. You see that? That's kind of what you have filled in on this side. Now on the client side, there's also a buffer, right? And it's currently at 1, hasn't received any data. So it sends 725 of data, and now it has the server was at its own sequence 1 and act 1, right? So that's where it was. Now the server is going to reply. So it's going to do 2 things, let's say. It's going to send an act reply. It's going to send an act reply, but it will also send its own data, its own amount of data. Here, let's say, push act, and the length of this will be 1448. Okay, so it's sending its own data. Remember, this is 1, and this is 1448. Okay, in the buffer on the other end. Okay, so here it needs to acknowledge to the server, okay, you just sent me, my sequence is 1, but I'm going to act the sequence number that I got from you plus 1, 726. Okay, it's informing the client at 54,841 basically that information. Additionally to that, it is sending its own data, 1114. So here again, it's still at sequence 1 because it's just starting to send data, and it's still acknowledging that on its buffer it's got 726. Okay, and that goes to port 54841. Okay, and then finally then, we can say from port 54841, the client now is going to act back to port 80 the information that it just got, right? So this is going to be an ACK, and it's going to say, I'm still at sequence number 726, but I'm still, but I'm now ACKing that you just sent me 1448. So you just sent me this, and you basically, the next sequence number would be 1448 plus 1. So then it's going to ACK 1449. Do you guys see that? Does that make sense? How the sequence numbers are going to increment? Okay, great. So that's good. And that's the basic idea, okay, guys? So, beyond this, I just want you to get the gist of this idea, as a review, and then that's what you have to figure out when you solve your problem, okay? That you have to grab that sequence number and you have to plug it into the spoof packet. Otherwise, it's not going to be, because you have to get it exactly right in the slot where it belongs. Otherwise, it's just not, it's not going to accept it really because it wants it complete. And that's really the challenge here, is that, if you think of all these arrows as, if you think of all those arrows as packets, then you have to think in terms of the parameters that they should have in place there, right? So the parameters are the port numbers, as you can see over here. Obviously the IP addresses, and then that sequence number, getting it right. Now, Wireshark does help you out a little bit because the packet usually says, whenever you've sent data, it says the next sequence number is so-and-so. And so that can be a little bit helpful. But as I said, that's really the difficult part of the problem, about that pattern. So a little bit of trial and error. Be ready to work on that for a few hours. Everything else I'll give you, and it should be pretty straightforward. So basically, data packets must be ACKed either one at a time or several at once. But after data is sent, it must be acknowledged, right? So just keep that in mind. So that needs to happen. But in conclusion, the sequence number is incremented by the amount of data sent. All right, so now that we've talked a little bit about that, let's talk about some of the goals that we have in this attack. So, all right, so one of the goals that we have is basically to steal a file. So we'll basically it was three things. It was steal a file, reverse shell, and something like ls. So I'll start here actually on this one, and then we'll come back, circle back to that one. So when you get your on Wireshark, you'll have to go to, it shows like Internet Protocol, and then you'll go to TCP Protocol. In there, you can find the source port, destination port. You can find the sequence number and the acknowledgement number. You need to make sure that you don't use relative numbers like what I was using here, but instead that you use the absolute numbers. And that's a setting basically in Wireshark. Your book has the details there of how to get to that. So one idea is that you want to look at the packet the last data packet sent from user to server, okay? So you can always click on all the packets and look at the last packet, okay? Obviously, you type something in the telnet and then you don't do anything, right? Let it just sit there for a while, let it settle, and then go into Wireshark. Make sure that you're not running things in the background, that you're only capturing telnet packets or TCP packets. You look at the last packet in the server, okay? From user to server. So the last packet from user to server. There you will go in and you need to find, you know, all the parameters that we've discussed, and also you need to find out the sequence number, okay, in the next packet that you should use. So you need to figure out, okay, if I'm going to send a new packet, what would be that sequence number? The absolute sequence number, which is what you need to encode in your packet. Okay, and that Wireshark will tell you. So it's not like you have to calculate, okay, how much data was sent, what was the, Wireshark should give you that data. Right, so usually if the data length is not 0, Wireshark will calculate this in next sequence number, okay? All right, so then the next thing you will need to do is you will need to construct the packet, right? So now you need to construct the packet. So now we can talk about that. As you know, you're plugging in your spoof packet in the IP and the TCP, but there's also the payload. And the payload is going to be the thing that you want to send. So usually it'll be something like PWD or LS, plus there's 2 more parameters that you have to put in. And that has to do with the fact that whenever you go in the terminal and you type LS, then you hit enter, right? You hit enter, and that enter then allows the command to take place. Well, that enter is represented by 2 characters, and I'll give that to you shortly, but just be aware of that. You need to have that enter sort of encoded in there as well. All right, so the payload of the TCP packet is actually the actual command that would, that you would run on the server, basically. So one of the things that you have to do for this example is you'll create for this one, right? So we're working on this one. You will create a secret file. So that's just a text file. Put it somewhere in your file system, on the desktop somewhere, and just call it secret.txt. So the idea is that there would be a top secret file in the user's account on the server. And then you want to print out, obviously, the content of that file. You can use the cat command from Linux. But the problem is if you just send cat the file, the output will only show back on the client, right? But you want to see it as a third party, as an attacker. Because remember, all data flowing in that telnet connection flows in that direction. It doesn't actually go to attacker. So we need to figure out, okay, even if I send a command, something like cat, secret.txt, I still need to find a way to have it make its way to the attacker, right? So that's really part of the payload. The payload needs to be a little bit more complex than just cat and secret. Okay, so let's think about that then. We have, again, client, server, and then, we have attacker, obviously. But there's an established TCP connection between those 2. And then attacker needs to spoof a packet. So even if attacker spoofs a cat secret .txt, the contents of cat would only go to the client and not back to the attacker. So that payload needs to be modified further. Okay. So what we need is to do some kind of a redirection, right? So we're going to do a redirection to print out the contents, and that's basically at that point it's just playing with Linux. So we can create on the attacker machine. You can so on this machine here you can run a command called nc-lv9090, and that basically just means that you've opened up port 90. So now port 90 is open here on the attacker. Okay, it's basically listening. Okay, so now what you need to do is you need to insert a command that reads the file and then sends the output to netcat9090. All right, and so that's the payload basically of your packet. So the spoof packet payload will be, should be cat, right? The secret file, let's say it's in home seed desktop, right? So then secret file.txt, and then you're going to redirect, if you remember, that's just a symbol for redirection, and you're going to send it. And here, Linux has these devices, right? So it has actually a way of sending stuff out into the network by using the device TCP. So device TCP, and then we can specify just the IP. So let's say that this is 192.168.1.3. This is 192.168.1.4, and then this one could be 192.168.1.7. So then we're going to send it to 192.168.1.7 on port 90. Does this make sense, guys? So that's basically what you have to do. You have to build a spoof packet, but the spoof packet, as part of its data, needs to carry this payload that I just described here. Right? So it needs to carry that payload there. That payload, when it delivers, it grabs the file, which is here, secret. Right? So it grabs secret, redirects it back to the devices in the computer, in the server, and the server Linux basically has in the file system this notion of devices, which are represented as files, and this allows you to send the data out. But it has to happen within the server, and the only way for that is for you to hijack a session in this way. Okay? Does this make sense, guys? Are there any questions so far?
I do have a question. I was looking at the lab manual and doesn't have this part in there. At least I don't see it. So I don't see the looking for the secret file inside the lab manuals.
But the PDFs, you mean?
Yeah.
Right, but what I'm saying is, that's why I said sort of at the beginning that.
Well, yeah, I was just going to say, so we just do this in addition to the lab manual?
Do these three things only. Read the lab manual, but sometimes I change things a little, so I want you to just do these three.
Okay.
Make sense?
Yeah.
So that's it. So on that problem, that's sort of what I said. I'll write it again in the when I create the link. But as I said, you don't have to do, like if in manual it says now do it in NetWalks, now do it in C, now do it in SCAPI or anything like that. Use any method that you want. You only have to do it once. Do you understand that, guys?
Yes.
as I said, I just, I'm modifying it a bit. And then the other thing is, I just want you to do these three things. So I want you to send an LS and view it. Obviously, you can only view it on the client, right? You can't view it anywhere else. That one is impossible. But the other two, stealing the file and a reverse shell, you could do directly for the attacker. I just showed how, right? So for the stealing the file, the trick is that every time it's the same, basically the same mechanism, same pipeline. I just want you, the payloads are different. 3 different payloads, same everything else. So LS, PWD, or steal a file, or reverse shell. Any other questions about this one, guys? Okay, so it sounds like you guys understand the idea. So netcat, you probably remember from 372 is a very, it's called the Swiss Army knife of Linux, I think, or something. It's a pretty useful tool for creating tunnels. Right. On Thursday, I'll just leave Thursday again as an open lab, work on this one, ask any questions, demo. It is the last one. I really want to be done with TCP IP this Thursday, right? Because next week is the exam. And then probably on that Thursday, we'll do intrusion detection system. So we're moving away from attacks and into defense. Okay. I will show you though. So I've shown you basically the payload. Okay. So the payload is there. Okay. Just keep that in mind. And you could do this for sending, that's TCP. There's also UDP, but you only need this one. So as soon, hopefully, if you do this correctly, if you insert the packet correctly into the server, you will, of course, what is the output, you might ask? On the attacker's terminal where you ran this one, right? Because remember, you run this one on the terminal of attacker. And then this payload needs to come in as, this command here needs to come in as the payload of the spoof packet, okay? As the payload of the spoof packet. All right, so basically if that part worked, what you will get is the contents of secrets. So obviously when you do your lab, show me, here's the contents of my secret, your name or something. And then here's my name as it comes out after I run the command in the output of netcat over there. Okay. All right, so that should be, so, whatever your name is. Now let's take a look at, how something like this can be done with our SCAPI code. Okay, so I'm going to give you the SCAPI code again. No, not brain surgery here or rocket science. It's just a simple Python code script. And it's actually exactly the same format. All semester, when we do intrusion detection, firewalls, whatever, VPN, we're pretty much always going to be using the same code. Okay, so let's call this one SCAPI Tcp Session Hijacking. Did I do that right? Okay, so let's take a look at the code. Again, you'll do import. This one's pretty easy. It's not even, because you're doing this manually, right? You guys, if you want to just do it manually, I'm assuming you then are using Wireshark to figure out the pattern of the sequence numbers. and then once, and all the other parameters of the session, and then now you need to populate your script. So this is only one of the spoof SCAPI codes instead of the sniffing ones, or sniff and spoof. So this will be import. So this will be import sys, okay? And then from SCAPI, dot all, I'm going to import all. All right, so now what do you need? Same thing as before. We're going to spoof a packet. We need the layers, right? So IP layer. And we're just going to, IP. What do we plug in here? Source. These can be hard-coded because they're not going to change. Obviously, they're just your machines. I'm just taking some here from the book, some IPs, and then this destination, 10, 0, 2, 69, like that. You see that? That's basically how that works. Then we can do the TCP layer, as you know, also. So I want to point out, right? So one of the reasons about doing this and understanding how, starting with the attacks, is that if you know how the attacks are usually crafted by spoofing packets, is that can better illuminate you when you defend, right? So now you can think, well, the IP layer will have this, the TCP layer will have this, the payload will have this. That's the pattern that I need to, so then I need to think in terms of defense, okay, how do I, deal with these kinds of things, okay? So here we have TCP, and now, it's going to be like source port. Remember, this is going from client to server, right? Client to server. So it's going to be probably source port is, it's whatever we were using. I can't remember. 54841. Right, 54841. And then the destination port, obviously that won't change either. That's 23, right? Because this is a telnet problem. All right, and then the flag here for this, for adding, it's A. Okay, so that sets the flag, the push flag. So flags equal A, comma. Now here, you need to get these numbers right. Sequence number, right? I'm going to put in 95.66.0.6610. And also the ACK number, 37.917.6610. That's really the trick, right? This one in particular is what's going to make this hard, figuring that out, because although I don't know, you might just get it immediately. I know when I've tried this problem a couple of times, I always have to really think, try a few, try it a little bit until I figure out the pattern. Right, and then plug in the sequence number there. That completes basically the TCP layer. That's the session information. And then the thing that remains is the payload. So the payload, create, a little variable here. Let's call it data, whatever. You can call it payload. And then now plug in your value. So usually you start with this -r, and that just means that that's the example I gave you before. So let's say that you have a buffer over here and you had a situation where, you inserted your bad code here, right? But the bad code has that R. So if there's some kind of a little pattern in the way that they're sending, like one byte at a time, you might get lucky. You fill in the bytes, and then this whole thing data gets read in, and it'll be treated as two things. It'll be treated as everything until there and then everything like that. So that way, regardless of this being incomplete, it still runs. It'll maybe fail, but then the next one still runs as a new one. Versus if you didn't have that in there, then it would treat the whole thing as an input and then it would error out. So at least by having that parameter before, it only makes, you know, the first part error out, but not the last one. All right, and that's the reason why, you know, you can include that symbol in there. Oops. It'll just, if there's nothing in there, it'll just get ignored. Regardless, you'll get what you want to run. Okay. So then after that is really just the command that we had before, the one that we just defined here, the cat command with the redirection and everything. So then we can do, in here, it would be cat home, you know, whatever we said, right? So seed, I think it's desktop. This is a space, by the way. So these are spaces. This would be secret.txt. Put whatever, you know, your name on there or something. Then obviously the redirection happens. This should continue. I'm just out of room here, so I'll continue down here. And then, you know, send the data to the dev TCP. And then it's going to be the IP address, in this case, of attacker. So let's just do it like this. So as you know, this is attacker. So then we can say this is 0.68, 0.69, and let's just say this is, you know, dot, I don't know, something, 17. All right, so then this would be 10.0.2. 17. And then we're assuming, of course, that this is already running. So 90, 90. And then finally, this same symbol over here, we want to add back here just to make sure that, you know, it runs. So that way we encapsulate it in such a way that regardless of anything in front or behind, this will execute correctly. And that allows our attack to work really well. Finally, we've got all the pieces of the packet, so we can just piece it together, basically. Oops. So this is going to be IP layer, and then, you know, / as usual, TCP layer. So this should be now so easy for you, you know, / and then finally data. Okay, if you want to look at the packet, ls packets, of course, and then finally you send it out. So it's verbose, cool, 0, and that's it. So as you can see, very similar to all the other ones, except that now we do have payload, okay? And we have, one of the things that we will see when we start looking at the intrusion detection is that intrusion detection systems actually signature-based intrusion detection systems have a tendency to look at payload quite a bit, okay? So I think, you know, like more than 50% of all the signatures in an IDS are payload related, at least the last time I checked. All right, so I've talked about that problem. Obviously, if this doesn't work, the most common error, sequence number. That might be the thing that is the biggest challenge, okay? Any questions?
I have no questions.
No questions, all right. All right, so that's good. Good. All right, then the last one is oh, actually not the last one. We got two more, right? All right, so then now we can do the reverse shell. So the reverse shell should be pretty similar, right? Reverse shell, pretty similar. So it's going to be the same code. So I'm not going to repeat the same code. So obviously, you need to, again, I would recommend, honestly, whenever you do one of these attacks, kill the telnet connection, restart it again, get everything new. Because once you do this, there might be some strange packets going around. Like, you know, you get this packet and the server will try to acknowledge to the client, not to the attacker, but then the client is going to say, hey, I didn't send anything. And then you're going to get these strange packets going back and forth. So a better approach, what I would say is, whenever you're going to run one of these three attacks, break the session, start it again, start capturing telnet. So kind of start over from scratch every time. All right, so now we're going to look at the third one that I want you guys to work on, which is, yeah, this one, right? So we've done the homework. We've done that one. And now reverse shell, we'll look at reverse shell basically. And it's pretty much the same thing. I mean, same script, but it's going to be the same script, but obviously what would change? Well, the parameters will change again, obviously sequence number, all that. And in particular, the payload, right? The payload needs to be a little bit different this time. So I won't give you all the code. I'll just really talk about the payload here, which is basically we need to sort of redirect the shell, right? So as you know, in Linux, you know, every user has a shell, and we just need to figure out a way to, and so that's called reverse. That's called reverse shell. Can you guys hear me? You guys, are you guys still there?
Yeah, I hear you. Just
Yeah.
Yeah, we can hear you.
Yeah, it just gave me an error here. Yeah, the internet, something happened to it. Okay, all right, but you guys can hear me. So the last part is, as I said, the session reverse shell, which is this, you know, this is basically, again, the same idea. We are going to create we're going to redirect. So think about it. We're going to redirect sort of to the same thing, to dev. Oops, I don't like this color. This one's right. All right, so we're going to do the same, redirect to the same device, TCP, whatever the IP was, 10.0.217. And port 9090. So that means, obviously, again, you need to run netcat on the attacker, right? So netcat needs to be listening, and you're going to redirect. So you already know how to send something, the output from cat, out to the network, right? For the reverse shell, we need to do the same, like the same thing, but instead, we just kind of redirect bin sh. So this allows, or bin bash itself, dash I. So this will allow us really to establish a connection, right? So it's to establish a connection from our own server to the bash of that computer. That's basically what we're doing. So if you think about it, it's like these are the computers. This is the server. This is the attacker. And we're going to run basically like a bin bash, bash basically. You can, so this would, like that, right? So it becomes its own terminal. And then this is linked sort of in a tunnel to that port 9090. And so now when you type something here, it's like you're typing it here. And you've literally then, and this is the bash, so it's going to interpret all the commands just the same. And so basically you have a terminal to the server, okay? So the idea for this one is going to be pretty much the same thing. There's a little bit that we have to do because otherwise it would just be a one-way connection. That's the only little trick that we need to add here, is so that we don't have just a one-way connection, but a two-way connection, right? Back and forth. But ultimately, though, this is the command, right? Like that. So this whole thing is not enough because the bash program uses both standard output and standard error devices for output. So we also need to redirect the standard error device to the TCP virtual file. So all we have to do, if you remember in 372, we talked about redirection, right? And we can do this by adding 2 and 1, and then 0, and in this direction, like this. Like that. So that's the full command, and that basically should allow us to have a two-way communication so that we can send commands back and forth, right? It's like they can exchange the data basically. Okay. All right, so that should be the whole command for this. Oh, yes, sorry. And then the last part actually is the the -r, and then at the end here also -r. So that will be the payload that basically you just have to type this in here for the reverse shell code, okay? This will work. So this will work. What I wrote here. So these are just, this is more on the Linux side. It has to do with redirection. There's a pretty good explanation of this in your book in page 353. You can take a look at that. I don't want to read it to you, but it explains really well it's just so 2 and 1 are the standard error and standard output, right, of one process. And then that allows you to send the data from 1 to the end of the tunnel. And then the 0 and 1 is basically like doing the opposite, getting the data from the other end. You can see that it says here, you know, we are getting, if you try to type, if we only have this, right? If you try to type anything at the shell prompt on the attacker, we do not get anything back. So we are missing one more thing for the shell, which is the input from the attacker. At this point, the shell program on server still gets its input from the local input devices. And that is why we can type commands on the server. So we need to get the shell program to use the TCP connection for its input device. You see that? And that's what this is doing. So we can achieve that by adding this part, that term. We can achieve that by appending, you know, at the end of the command. This means using the device represented by the file descriptor 1 as the input device, which is file descriptor 0. Since file descriptor 1, which represents the standard output device, is already set to the TCP connection, the same connection will now be used as the input device as well. You see that? So basically, you're saying that your input should be this. Okay, whatever comes through there, that should be your input. And that's what this addresses. And then this one addresses taking the data to the server. So you get back and forth on there. Any additional questions, guys?
Hey, Professor, when is this lab due?
This lab would be due, we have a lab due this Thursday, correct? Which is the
Spoofing.
the spoofing one, right? And so this one, I assume you guys have done the denial of service by now and the TCP reset. So really all that should be left is session hijacking. So this is where I asked you the question. You want to break you want to break this into 2 labs, or you want to submit everything as one single lab? What would you guys prefer? There are disadvantages in the sense that if this is very complex, it's a whole lab. I would prefer separate lab. Okay, so do you guys, as I said, you get more easy points, right? Because the TCP reset and denial of service are easy, so that you secure those points easily, but you put these points a little bit, because it's harder, but it's only one very focused problem. So some of you say they want 2 labs. What about the rest?
Is this for the entire contents of the TCP IP attacks folder or section?
Yeah, so the TCP IP attacks lab, you have denial of service, TCP reset problems, which were 3, and then now TCP session hijacking, correct?
Yes.
So would you prefer 2 labs or just 1 lab combined of all?
If it's 2, does that mean one of them is due this week and the other one is next week?
Yeah, obviously, no. It would mean that the TCP, we have spoofing due Thursday. So therefore, I'm not going to have 2 labs due Thursday. So I could make denial of service and TCP reset, the 3 parts of it, due a week from Thursday. And then this one, TCP session hijacking, 2 weeks from Thursday. So you'd have a lab due each week.
That sounds good to me.
You say, okay, everyone else, okay. That's what I was thinking, but.
Yeah, that's fine.
I'm good with 2 labs.
Can have the lab due the week following the test, so we don't have the test and then a lab due on the 2 days later.
Okay, so let's see. You want spoofing due this Thursday. Since we have an exam Tuesday, you want to study, therefore no homework due that Thursday. But then the 2 labs separate, but due on the same day. Is that what you said?
Well, anything that doesn't have us have a lab and a test within the same week.
No, that's fair.
I think that would be a little overwhelming.
let's do this. Let's do this. All right, let's actually do this. This actually works. Spoofing due this Thursday, right? No lab due the week of exam. And then the following week, set for the TCP reset and denial of service. And then we'll just see about spoofing. Let's see how it goes. And we'll figure it out if you guys are all done or if you need extra time. Make sense?
Yes.
Yes. Okay, thank you.
Yes.
All right, so yeah, that's good. So I like that you're gonna study for the exam, so that's a good thing. Okay, so let's agree on that then. But at least as far as me discussing the topic, doing a lecture on it, I am almost done. I just have one last thing to do. And then, you know, kind of open lab on Thursday. All right, so this I think concludes TCP reset. The rest of this you can really just read in the book, and it's pretty clear there. But I finished basically giving you the payload, okay? I've given you the payload. So again, in conclusion, use the same script. Obviously, you need to get the right numbers here. The payload for reverse shell is this one, and that then gives us these two. Okay, so these two are done. And now I just need to give you the last one. All right, so I want to give you this one. This one, I don't know that it's in the book. So, but I will give you most of the commands for it. Again, you can try it with either, we have enough time, so you can try it with either NetWalks or you can try it with Scapy. Okay, so we're gonna do that one.
I have a question for you.
Go ahead.
In regards to the exam for study material, I know it's pretty much, you know, from the beginning up to now, what can be covered, but is there like a specific idea of what items you'll...
Not so much C, okay? C is not really, I wanted to show you guys what's the thing under the hood with C, right? But don't worry about like the mem copy one, for instance. That I can tell you. Because I think the Scapy code really captures everything really well. So it's really about understanding that, sniffing and spoofing, and then understand the attacks. Like what is TCP session hijacking, what is, you know, the reset, the denial of service, all of that. So just understand that concept really well. If you think about it, all of this, the class is not about learning how to be a hacker or attack or anything. It's about understanding how this class of attacks works, right? Which we've called the class of attacks of spoof packets, so that we can think better about how to defend against them with intrusion detection systems and firewalls, okay? Which, like I alluded to today already, a lot of it is look at the payload, right? Look at the payload, what's in the payload, and that kind of thing. Make sense?
Yes, thank you.
All right, good. Yeah, so if you've done the labs, if you've been listening to the, it should be pretty straightforward. Okay, so the last one then is this scenario, right? So a type of an LS. So I have like this, and like that, right? So again, client, server. This one is the least, let's say, like elegant of the problems, but it underscores an important thing. It underscores the fact that the attacker, if the attacker doesn't use some type of redirection, when the attacker inserts a packet in here, an attack packet, the reply will only be sent in that direction. Okay, so the attacker never sees anything. So you guys, when you show that this lab worked, you're literally just going to see output here in the client. Or you can definitely see it in Wireshark. Okay, so sometimes you may not get it to print on the terminal, but I'm fine if you just show me the packet this packet, right? So a response packet given this packet that was sent from server to client containing information. So like if this one contains PWD, the command PWD, then this should send something like home, seed, desktop or something. So it sends the path of the current working directory, okay? So again, if you did this in Scapy, pretty much in Python, same code as before, but what is the payload? Okay, the payload, as you've seen now, like that, and it's whatever you would type on the command line, right? So PWD, that's it. You see that? Pretty simple. I mean, it's literally that simple. So now if you did usually students, I prefer that you do PWD just because I know what I should be looking for there. So let's see. Yeah, but that's basically, so I guess I shouldn't have made this. So that's the payload for that, but just be aware, you will not get anything on the attacker. It's only on the client side. And you either see it with Wireshark because you look at the packet, or you see it in the actual terminal itself. Accomplishing this one in NetWalks is a little bit more challenging, but it can be done. So for that, I will just point you to the commands, which I have already provided on Brightspace. So you should be seeing Brightspace now, or here, sorry. Brightspace, and if we go to 454, under content, in TCP IP attacks, there it is. If you look at this link, it opens. Those are the NetWalks commands. So it uses NetWalks 40. I've already provided all the flags except for like source, destination, sequence number, and ACK number, and the data. I guess I forgot to provide that. That would be the window size is just whatever the window size of the last packet was. So just copy that. And then that is, let me give you that. I forgot to include that. So for that payload, it will be, it's just written a little bit differently. So you have to write it, that -- TCP data will be PWD and then 0D 0A double quote. So that's double quote, single quote, PWD, single quote, 0D 0A. That. And this is basically equivalent to that PWD R. Okay, like the new line character, because remember at the end of the day, the answer is carriage return and new line character. So it's 2 characters actually, but that, you don't have to worry about that. That's just the encoding. Just be aware as we start going down, right? This becomes that, and this would become that at a very low level. So in conclusion, if you use the NetWalks tool, that's the parameter for the payload. Okay, and I gave you the 2 NetWalks commands. You kind of run them one after the other. Or if you use the Scapy approach, I guess, yeah, here is the payload. Okay, you only have to do it with one. I'm really just trying to give you options of to try things out, play around with things. All right, so that's basically all of it, I think. All right, so the last thing before I finish and before I forget is let me set those homework assignments. So I'll modify this a little bit later, but I just want to, so I don't forget. All right, so TCP spoofing, that's due. Yeah, this week, right? So this one is, these are due this week. And then, yeah, so this week you have enough time. And then no exam, you have an exam next week, so no homework next week, but you would have the part of the TCP IP 2 weeks from today. So let me create a new assignment. I'm going to call it Part 1 TCP IP attacks, right? And complete the following. As discussed in lab. One, denial of SYN flooding, basically. SYN flooding and SYN cookies. So remember also we discussed SYN cookies for the exam. That could be a nice question. So SYN flooding and SYN cookies. And 2, TCP reset attacks, which was, remind me, I know there's one that's video streaming. Video. Oh yeah, I remember. So break. Break. Telnet session, SSH session, and video streaming session. Right? Okay, the due date now, we agreed. So today's the 9th, homework. Sam, so it would be due on the 25th. Is that correct, guys? Did I get that right?
Yeah.
Okay. All right, so it would be due on the 25th. Okay, so that's set, and then I'll set the other one, TCP session, depending on how it goes, probably the week after, right? But I won't create the link yet. Okay. All right. So if you have any questions, please stay and ask your questions. Otherwise, I think I can stop the recording.